In this video, we're going to talk about the definition of a parametric function and then dive into example 2 and talk about how to graph a circle. So the definition of a parametric function is as follows. If x and y are functions such that x equals f of t and y equals g of t over an interval of t values, then the set of points x, y can be defined as f of t, comma g of t. So this is just saying that each x and y are determined by t values. The graph is called a parametric curve, and the equation is called a parametric equation. So instead of calling it just a graph, we call it a curve, or a function. It's definitely not a function, but it's a curve and an equation. The variable t is the parameter, and its domain is the parameter interval, and we call that I. If I is a closed interval from a to b, then the point f of a, g of a is the initial point, and f of b, g of b is what we call the terminal point. So the initial point is the starting value, usually t equals 0, but it could change. And b is going to be your final point or your final time. All right, moving on to example 2, we're going to talk about how to graph a circle. So we're going to be given the graph x equals 2 cosine of t and y equals 2 sine of t from 0 to 2 pi. We want to find the initial and the terminal points and the direction in which the curve is traced. So again, you're going to want to find initial and terminal points and the direction that it's traced. So the first thing we're going to do is we're going to find the initial and the terminal points. So my a value is 0. So I need to find x of t when t equals 0 and y of t when t equals 0. So then x of 0 is going to be 2 cosine of 0, which is 2 times 1, so it's 2. And this is going to be y of 0, which is 2 sine of 0, which is 0. So this makes my initial point 2, 0. Then we need to find the terminal point. So my terminal point is when b is equal to 2 pi. So we find x of 2 pi, which is 2 cosine of 2 pi, which is 2. And then y of 2 pi is 2 sine of 2 pi, which is 0. So it turns out that my terminal point is also 2, 0. So this thing is going to start and stop at the same exact point. Now, in order to find out which direction it travels, we could plug in a bunch of values and see what we get, or we could just graph it on our calculator. So on your calculator, you want to go ahead and type in the equations, and then go ahead and push enter. And again, for my window, I know that it's going to be 2 sine, so I'm going to make this go from 0 to 2 pi, which is 6.28. And in here, you can actually just type in 2 pi, and it'll fix it for you. And then the step is 0.13. I'm going to change the step to 0.01, and the rest don't matter. It's just going to make it go slower. X min, I'm going to do -4. X max, I'll do 4. And same for the y. Then I hit graph. So I can see that it traced out like that. And I know it looks a little oblong, but that's because the view of the calculator is a little wonky. So we can see here that it rotated counterclockwise. So if I want to see that again, I can just change the step to like 0.11. Just change this a little bit, and then it'll regraph it. And I can see that it goes counterclockwise. Okay, so it said to describe the motion, so we're going to go ahead and describe the motion. So the curve makes a circle that rotates counterclockwise. So we're going to go ahead and take a second and look at this function algebraically. So we know the definition of a circle is x squared plus y squared equals r squared. And we know that x is equal to 2 cosine of t. And we know that y is equal to 2 sine of t. So if I were to plug that in, I'm going to get that. So when I plug that in, I get 2 cosine of t squared plus 2 sine of t squared is equal to r squared. So I get 4 cosine squared plus 4 sine squared. I can factor out the 4. And I know that cosine plus sine squared is just 1. So I get this is a circle with radius 2. So the algebraic equation would be that x squared plus y squared is equal to 4, which is exactly what we got in our graph. All right, on your own, I want you to go ahead and graph this function. Tell me the initial point, the terminal point, and the direction. And then I want you to actually create the Cartesian equation. So I want you to find it without any t's. So go ahead and try that now. All right, so step 1, we're going to go ahead and put those in our calculator. So these should be 3's. And I graph that and I get a circle with radius 3. So you're going to want to take this step to go ahead and draw that in your notes. And then just take a minute to recognize that it moves in this direction. And the AP test might ask you to draw something like that and then describe the motion. So this is a good, helpful tool. Okay, so my initial point was 3, 0. And my terminal point was also 3, 0. And it rotates counterclockwise. Okay, and then we need to go ahead and create the equation. So normally a circle is x squared plus y squared is equal to r squared. But I know that x is 3 cosine. And I know y is 3 sine. And then we're going to go ahead and just do some algebra. So my equation of my circle is x squared plus y squared is equal to 9. Now notice if it's cosine b sine of b, it rotates counterclockwise around the circle, moving in this direction. So if it's b that's positive inside, it's going to rotate counterclockwise. If it's negative on the inside, so if the inside the parentheses of sine and cosine is negative, you'll notice that it's going to rotate the opposite direction, so it rotates clockwise. So again, to formalize that for notes, x equals a cosine of t and y equals a sine of t gives a circled centered at 0, 0 with radius r equals a, and it's going to rotate counterclockwise. If it's negative t on the inside, it's going to rotate clockwise. And the value of a gives you the initial point. So it gives you the starting point and the terminal point if you do one full rotation.